Now today's lecture will be based on Volhard Zelinsky reaction, right? In short, we call it as HVZ reaction. HVZ reaction. That is Volhard Zelinsky reaction. So what we do in this reaction, we take carboxylic acid or CH2COOH. Fine? We first react it with red phosphorus and along with halogenation. Let me take X2 general. Red phosphorus in presence of halogen X2, and X2 is generally halogen is generally can be Cl2 or Br. Generally we take these two halogens, either chlorine molecule or bromine molecule. Fine. You end up with, initially we get acid chlorides or alpha halo acid chlorides or CHX C double bond OX. Alpha halo acid halides, right? Yes, sir. So we call it as alpha halo acid halides. Alpha halo acid halides, right? And in next what we do, we treat these alpha halo acid halides with water. We carry out hydrolysis. And finally our product is CHX C double bond OH. So this is our product, and this is called as alpha halo carboxylic acid. Our short form is alpha halo acid, right? This is called as alpha halo acid. This is our final product. So in first step what we do, we take carboxylic acid, we treat it with red phosphorus in presence of halogen molecule. Halogen molecule can be chlorine or bromine. We have this alpha halo acid, fine. And then alpha halo acid halide, then we treat it with water, then we finally end up with alpha halo acid. So the important condition for this reaction is that this carboxylic acid should possess at least one alpha hydrogen. This is functional group. उसके बाद जो पहला कार्बन होगा, that's called as alpha carbon. उसके hydrogens, they are called as alpha hydrogen. So presence of at least one alpha hydrogen is important, right? So there is simply replacement of one of the alpha hydrogen by halogen. We have a change. Yes, sir. इसमें क्या difference है? Product और reactant में क्या difference है? There is simply replacement of one alpha H by halogen, right? You got it? Yes, sir. Now important thing you have to remember here is that if you are taking 1 mole of halogen here, 1 mole of halogen, then you will have this type of product, alpha halo acid, just mono halogen acid, right? Now if you are taking excess of halogen here, then जितने भी आपके alpha hydrogens होंगे यहाँ पे, they all be replaced by the halogen, right? And if you are using excess of halogen here, then this product will be as such, or CXX single bond C double bond OH. कितने alpha hydrogen थे यहाँ पे? दोनों replacement किससे? Halogens, right? Depending upon the amount of halogen you are taking. If you are taking 1 mole, then it will be mono halo acid. If you are taking excess of halogen, then you are जितने भी इसमें alpha hydrogens होंगे available, fine. उतने replace होंगे किससे? Halogen. You got it? So let me directly go to the mechanism of this reaction. Mechanism of HVZ reaction. Now since in first step we are taking what? We are taking phosphorus and halogen, right? Yes. So let me take halogen here, suppose. Phosphorus is there, and suppose I take bromine molecule. Fine? So first of all what happens there is that there's reaction of phosphorus with bromine, and you get 2 atoms of this and 3 moles of this. You will get twice PBr3. Twice PBr3. Is it balanced? Yes. 2 phosphorus and 6 bromine, right? Twice PbR3. Now this is a reagent. This is formed after the reaction of phosphorus with bromine. So we end up with PbR3, phosphorus tribromide, right? Now what will happen in next step? We have this carboxylic acid, RCH2, C double bond O, OH. This will react with PbR3. It's a very famous reaction, fine. Now what happens with this PbR3 is that it replaces this OH group by halogen, right? It's actually a separate reaction, fine. So without going through in the details, what will happen in this first step, you have to remember is that there is replacement of OH of carboxylic acid by halogen, Br, fine. Halogen here is Br. It's a halogenating reagent, right? So it will cause the replacement of OH of carboxylic acid by halogen. So what you will get are CH2 single bond C double bond O Br, right? Okay?
Yes.
Now see, since we have carbonyl group here, this electron withdrawing group. Again, bromine is also electronegative electron withdrawing group. So these alpha hydrogens, they become acidic. They are highly acidic, right? Because of two strong electron withdrawing groups, these alpha hydrogens are highly acidic. Acidic means they can easily lost in the form of H plus side. So what will happen? If I write it like this, R CHH single bond C double bond OBr. This will go like this. A little bit of tautomerization will occur. Tautomerization. This is acidic H. I told you it will go like this, and this pi electron will move to oxygen. This H plus one will loss here, and it will add to O negative. So it will become OH. You will get a sort of enol, because in tautomerism there is enol formation. Fine. So what you will get? On CH double bond here. Fine. So there will be double bond here. COH single bond B. This is enol form. En means double bond is here, all means OH group. You got it? So this is the enol form, fine? So after tautomerization, you end up with this enol form of this Si halide, right? In next step, now this is R CH double bond C OH Br. Since we have this Br2 molecule in the reaction, we have Br2 molecule in the reaction. This Br bromine molecule will undergo hydrolytic cleavage. Hydrolytic cleavage means these pi electrons suppose will move to this carbon, this bromine. This will get Br negative, this will become Br plus. At the same time, this OH bond, इसके दो इलेक्ट्रॉन नीचे आएंगे ऐसे, and these two electrons will move to this carbon. This will get negative charge. This negative charge will pick up this Br plus. You got it? So it will be like this. This will occur in one step. At the same time, यहाँ से जो H plus निकलेगा, this will bind to Br minus, and there will release of HBr. You got it? Now what will happen to this molecule? It will become RCHBr. Now Br will bind to this, because these two electrons will move down. This carbon will get negative charge. This negative charge will pick up Br plus. So this will bind to this alpha carbon, right? So Br will bind over here. So what will happen? You will get single bond C double bond O Br. You got it? Now this is called as alpha halo acid halide. ठीक? जो हमने फर्स्ट स्टेप में बनाया. Alpha halo acid halide. ठीक है? Fine. Now in next step, it's very simple now. What you will do is that you will this alpha halo acid halide will undergo hydrolysis. We just add water. So I'll write once again RCH C double bond O Br. This is Br over here. Now water is here OH2. Two lone pairs are oxygen. Now what will happen? This CO bond will undergo shift of pi electrons. Pi electrons will go to oxygen. This will become O negative. This will get plus. This will attack here to this one. So what you will get? R CH single bond. Now this will be O minus single bond Br, and here it will be OH2. What molecule bind over here? Plus charge on this oxygen. Got it?
Yes, sir.
Next what will happen? One of this OH bond will break. इसके दो इलेक्ट्रॉन कहाँ जाएंगे? यहाँ. You got it? So what you will get? R CH. Now here is Br. I forgot to write. Br is here. So now it is CH Br single bond C O minus. Now this is OH single bond Br. And in final steps, since this bromine is good living group, it will move from here. This carbon bromine will bond break. This will remove as Br minus. This carbon will get positive charge, negative charge will move down. So what you will get? R C H Br single bond C double bond O. Now this is our final product. What is our product? Alpha halo carboxylic acid, right? So finally what you have to remember is that in acid reaction, in first step we treat the carboxylic acid having at least one alpha hydrogen with a mixture of red phosphorus and halogen molecule. You end up with alpha halo acyl halide, fine. Then in next step we just simply carry out hydrolysis. You end up with alpha halo carboxylic acid, fine. Now important thing you have to remember is that if you are using 1 mole of halogen, then your product will be monohalo acid. Now if you are using excess of, then it will be polyhalo acid. Polyhalo means jitne bhi aapke alpha hydrogens honge, they will be all replaced by what? Halogen. You got it? Should I move ahead? Now some questions.
Sir,
Yes?
we are using, sir, only bromine and chlorine, sir. Why not fluorine, sir?
Because I told you if you are taking fluorine molecule, I told you those reactions are highly explosive.
Yes, sir.
Right? So that's why we avoid those reactions. And in case of iodine molecule, there is some sort of reversibility. Right? So we can't end up with the product. Right? So that's why we are avoiding these fluorine and iodine. Right? For example, if we have this molecule CH2 COOH, if you react it with, first you are reacting it with red phosphorus along with suppose Cl2. In the second step you carry out hydrolysis. What will be the product? Here is 1 mole of Cl2, right? Now same molecule, if you carry out its H's reaction, red phosphorus in presence of Cl2 excess. In second step hydrolysis, what will be the product? Can you make the product now?
Yes, sir.
यहाँ पे इस वाले में पहले क्या बनेगा? When you are taking 1 mole of Cl2,
Sir,
just one H will be replaced by
Yes, sir.
Cl. If you are taking excess, फिर दोनों यहाँ पे 2 alpha hydrogens है, both will be replaced by chlorine, right? So in this case, your product will be CHCl COH. In this case, product will be CCl COH. So you have to remember very cautiously whether there is given 1 mole or excess. So likewise you will get the product, right?